what you want to find out if A causes B, if you want to look at a causal relationship between variables, that's where you'd want to do an experiment. An experimental method, you make inferences about causality. What variables cause changes to another? Now realize this is something that I think that people generally would like to know. We would like to know what causes what. When we're driving our car, we certainly would like to know that pressing on the accelerator will cause our car to move forward, and pressing on the brake will cause our car to slow down. And we are trusting in that it does. So we want to be able to make inferences about what causes what. So in psychology and in studying personality, we're trying to create a situation in which a researcher can control and manipulate differences in one variable, and then observe the effects of those differences on another variable. Okay. So, if we want to talk about, well, what makes an experiment? Well, one aspect of it is that an experiment manipulates variables, specifically manipulates one or more independent variables. And we'll talk about what an independent variable is. But this is something that is under the control of the experimenter. The experimenter makes changes in that particular variable, creates those changes. Another aspect of an experiment is that is random assignment to conditions. You are not picking and choosing who goes into what group based on who you like and who you don't like or whatever. You need to be able to say everybody has an equal chance of being put in one condition or the other. Exertion of experimental control. In this case, the experimenter is creating a situation in which other potential variables could be essentially controlled away, kept out of the equation. These variables are called extraneous variables. Variables that are not really what you're interested in, but can nevertheless cause problems in your study. When you do real-world research, when you do research in a natural environment, lots of things can happen. Rain can fall, car accidents can happen, all sorts of things can go on that can interfere with the behaviors you're observing. Okay? If you're observing lunchroom behavior in a cafeteria among children, and then they have a fire drill, well, that's kind of an abnormal circumstance that's going to, change people's behavior. In an experimental situation, the experimenter controls the environment. Often it's done in a laboratory where other kinds of possible interfering variables can be kept out. Finally, an aspect of an experiment is once you make those changes, you make that manipulation, now you need to find a way to measure the effect of that manipulation. So in other words, you're being able to say that the condition that you created caused changes in another variable, and that other variable would be the dependent variable. So let's talk about that. So the independent variable, that is the variable the researcher manipulates. That is the cause in the cause and effect relationship. So the researcher, okay, so let's say the researcher is looking for, if you take a look at this particular example here, let's say a researcher said, I wonder if there is a relationship between emotional support and academic performance. Okay? Very interesting idea. You want to look at the relationship between those two variables. Now, you can do a correlational study to find out that relationship. You could ask people about how much emotional support they had, and you can then record what their academic performance. You can find out what their GPA is, and you can compare their scores on an emotional support measure with their GPA and see if there's a correlation. In that case, you're not doing an experiment. You're just doing a straight correlation between those two variables. Fine, you can certainly do that. However, if you wanted to see, well, maybe we want to go further. We want to be able to say that emotional support actually can cause changes in academic performance. Now, that's a more compelling question. Now you're looking for cause and effect. So, here's what you would do. You want to find a way to measure that conceptual variable, emotional support. See, emotional support would be an example of a construct, a conceptual variable. Emotional support. Many different ways in which you can define what the heck emotional support is. All right? So, you want to measure emotional support. One way you can do it is, one way in which you can perhaps manipulate emotional support is perhaps you can ask a group of parents to give a certain amount of verbal praise to their children. So you can operationalize it by saying, okay, we're going to have your children work on a various problem, and we want you as the parents to give praise. So the parents would essentially be giving praise to the child in the problems they're working on. And you can take another group of people and another group of parents and basically you say, don't tell them anything, don't give them any praise. So you're comparing the parents who give the praise to parents who don't give the praise. And you as the experimenter are controlling that because you are telling one group of parents to give the praise and the other group of parents to not praise. Make sense? Okay. Now in that case you want to find out if that manipulation, that variable, parental verbal praise, can actually cause changes in academic performance. And likewise, the effect of this, the dependent variable, what you're measuring after that manipulation, is something that you also want to be able to create an operational definition for. So you have math achievement scores as an operational definition of academic performance, because again, GPA is one way to measure it. Achievements, reading comprehension scores, whatever you want it to be. But in this case, you could say math achievement scores on a test, on a math test, would be a good operational definition of academic performance. So now you're looking at the operational definition, manipulating parental verbal praise, with the effect being increased math achievement scores. That's what you're predicting. So you are predicting that with the parents who praise, the group in which the children are praised by their parents are going to do better in math than the group who is not praised by their parents. When you can do that, and again, trying to control for other variables, making sure that the children are being treated the same way, except for one group is getting praised, one group isn't. And, with use the experimental method, you can exercise control. You can rule out those third variable explanations. You can eliminate other extraneous variables. And you can essentially make sure that everything's happening at a particular rate of time. It's not happening across 2 months. It may be happening in a set period of time. And again, if you can introduce that level of control, if you can manipulate the independent variable, and you find that there's a difference between the group that got between the group that got the treatment and the group that didn't, then you can say that there is a cause and effect relationship here going on. Unfortunately, there are some disadvantages to using in experiments. It's often an artificial situation. It's usually done in a short period of time. You're not going to keep someone in a laboratory for 6 months, for crying out loud. And the manipulations often are weak manipulations. You're not really going to create some change that's going to be so dramatic that it's going to cause a lot of people anxiety. Some variables can't be manipulated. I can't say, for example, whether or not you're male or female, your gender would cause you to do better in school. There may be a relationship between those variables, but I can't conclude that being male or being female causes you to do better in school. You can't manipulate gender. You can't randomly assign people to be males or females. So you can't make that cause and effect conclusion. Again, sometimes it's difficult to determine what it is about the manipulation that is responsible for the effect. So, for example, let's go back to the car. You press the accelerator, pressing the pedal on the gas on the accelerator causes your car to move forward. Is it really the pressing on the pedal, or is it the gasoline being injected into the engine that is causing it? See what I'm saying? So we need to be more clear about what it is that is causing that effect. And again, another problem is that you can do everything right. You can create a controlled experimental situation, controlled laboratory situation, but you just really can't possibly control all variables, all confounding variables, all those variables that could be interfering and could actually be causing those changes, but you're not aware of it. But you can't control everything. So that's that's a disadvantage. But again, it's still the best way we have as scientists of establishing cause and effect. Okay. So again, to kind of summarize, typically what you would see is in correlational studies, this is what you would use when you are examining naturally occurring characteristics. A person's self-esteem is something that's naturally occurring. It's not something that you're really causing. So aspects about someone's personality are usually naturally occurring, which means that correlational research is going to be very commonly used among personality psychologists. If there is a characteristic that can indeed be manipulated, then you can try to do an experiment. And again, an experiment is more powerful in that it can tell you cause and effect, while a correlation can't. What many personality psychologists will often do is they will often combine the effect of two variables, and that's important because it's too simplistic to say, just one variable causes changes in another, and that's it. That's very simple. Oftentimes, two variables interact with each other in a specific way that studying each variable alone is going to be misleading. Okay? This is an important issue. That's why many studies use interactions, because you have to look at two variables together. And we'll give you an example of that in a minute. And you could use correlational variables in a multifactor study. You could use manipulated variables, and you could use mixed variables. In other words, you could look at a correlation, or rather, you could look at an interaction between an experimental variable and one that's naturally occurring. Like, for example, let's go back for a moment to the slide describing the elements of the experiment. Okay? Go back to the slide here. Here we can have an independent variable and a dependent variable. You can manipulate the amount of praise a parent gives to a child for working on a problem. Okay? You could certainly do this, and you could certainly manipulate it. You could ask the parent to give the praise. The other group of parents, you ask them, don't say anything, don't give them any praise. What you could also measure in this case is the self-esteem of the child. Okay? Maybe there is an interaction between the emotional support and the child's self-esteem. For example, maybe the verbal praise is going to be very effective for children with low self-esteem, where the child who gets no praise is going to maintain that low self-esteem, but the child who gets a lot of praise, but the child with low self-esteem who gets a lot of praise, it's really going to have a positive effect on them. Perhaps the child with high self-esteem will do just fine whether or not they even get the praise. Maybe the high self-esteem children don't even need the praise. So maybe there's no difference between high praise and low praise, or no praise, with children who have high self-esteem. So there's an example where the self-esteem of the child is another variable that can be a potential interaction between emotional support and self-esteem, and it needs to be studied together. So anyway, let's go back to where we were. You can graphically represent an interaction here, let's say. So here's another example of an interaction. Let's say we're dealing with measuring anxiety. And that's kind of like your dependent variable, your anxiety, okay? Maybe you are going to suggest that that students who are in small classes will have less anxiety than students in large classes. perfectly reasonable to make that conclusion. Students in small classes have less anxiety than large classes. And if you look at the numbers here, you would say that would be true. And that would represent a main effect of class size. So for example, if you look over here, the number between 8 and 5 here. So looks like 7, right? So the level of anxiety would be a 7 for about a 7 for for students who are in a small class, but they would be about a 10 somewhere in between these 2 points for a large class. So the difference between 7 and 10 indicates that there is a main effect for class size. In other words, students in large classes, on average, have more anxiety than students in small classes. And that would reflect a main effect for class size. Now, if we're looking at sociability, is there a relationship between sociability and anxiety? So people who have low sociability versus people with high sociability. Now realize that sociability is not something you can manipulate. Sociability is something that is naturally occurring. But the students who have low sociability, their average anxiety is right in the middle over here, about 11. The people with high sociability, about a 5. It's about 5 here. So what that would tell you is, oh yeah, it looks like there is a relationship between sociability and anxiety. The high sociability people are less anxious than the low sociability people. But if you look here, and that would be a main effect for sociability. But over here, you have to look at the relationship between both sociability and class size if you really want to understand this relationship. Okay? If you look at just the students who have low sociability, if you look at only those students with low sociability, which represents this brown line over here, what you are seeing is that the students with low sociability, they are a lot less anxious in a small class than they are in a large class. So the average anxiety for the low sociable people in the small class is 8, and for low sociability in the large class is 15 up here. So there's a big difference here. But look at those who have high sociability. For students who have high sociability, it doesn't matter one bit whether they are in a small class or a large class. Their level of anxiety is the same. So if we are going to conclude, for example, that we should put everybody in small classes because it'll reduce their anxiety, the answer is no. It's not going to reduce everybody's anxiety. It's not going to do anything for the students who have high sociability, but it would be helpful for students with low sociability. So a better conclusion you get from this interaction is that the low sociability reacts differently to class size in terms of anxiety than the high sociable students. And that's what you need to know. You need to qualify the effect of one variable on the dependent variable. You got to take the other variable into account. If you only looked at high sociability students, you would conclude that class size has no relationship with anxiety. But if you separate it out, the high sociable and the low sociable, you'll see that significant interaction. Okay, so that's the end of the show. I wanted to just, just to remind you, the next presentation we're going to do is on Chapter 3, and that deals with personality assessment, realizing the importance of measuring personality and the various ways in which personality psychologists do it. Okay.